Hello students, so our next topic would be addition of vectors. We shall see how two vectors when taken together can be added to find out one single vector that creates the same effect as that of the two original vectors. So to understand the concept of addition of vectors, let's take an example of some, let's say a displacement vector, vector A, let us say, which is a displacement vector from the starting position O to the ending position P. Let us say the vector OP, which is also written as vector A, denotes the displacement of a particle that starts from O and reaches the point P. Once it reaches the point P, let us say it changes its direction and undergoes one more displacement, and this displacement, let us say, is in this direction. And let us call this final position of the particle to be the point Q and denote this vector PQ as another displacement vector B. So now the question is that this particle which has had two displacements, one is corresponding to the vector OP and the other is corresponding to vector PQ, what is the net displacement of the particle? Naturally, net displacement will be the effective displacement or the sum of the two displacements, right? Now, as we look at the figure, do we understand that the net displacement of the particle will be from its very starting position O to the very final position Q, which should be, how do we get that displacement? Just by joining the points O and Q like this, and we say that the vector OQ, which we can also call as the resultant vector R, will give us the resultant or the sum of the two displacement vectors OP and OQ, which we are also calling as vectors A and vector B. So pictorially, this is how we understand the addition of two vectors. Here we have taken an example of two displacements being added. We can take any other type of vector also. We can take two force vectors or two velocity vectors, and when we add them, this is how we shall show them pictorially. And how do we write them in expression? We write vector R, which is the sum of vector A plus vector B. Mind you, this vector sign over all the three quantities is very, very important. We cannot write here R is equal to A plus B. This will be wrong. Okay, we are adding two vectors to get a third vector, so we must represent all the three quantities in vector form. So from this figure, we understand that the resultant vector R, the vector R that we are calling as the resultant vector, it basically creates the same effect as the two original vectors create together. So this creates same effect as A vector A and vector B create together. So as we look at this figure, we would try to get a law, a particular law for adding any type of vectors. Now understand, if even if we don't try to add displacement, if we try to add two forces or two velocities or two momenta, we should be able to do that, and for that we have the first law that we call as the triangular law of vector addition. And this is nothing but just a statement of what we have understood in the above figure already. We will first state the law and then we will understand it in context of the above figure itself. So the statement of the law says, when two vectors to be added are taken as two sides of a triangle taken in the same order. Now we will understand this a little while after. What do we mean by taking two vectors in the same order? their resultant is given by the closing side of the triangle taken in the opposite order. Let us understand this statement while we look at the figure that we have already drawn above. See that the above figure also represents a triangle, isn't it? And here the two sides of this triangle, which we have taken as the two vectors to be added, vector A and vector B, which is also the vectors OP and vector PQ, they have been taken in such a way so that the head of the vector A coincides with the tail of the vector B. Vector B has its tail coinciding with vector A. So that when you draw the two vectors, you have the arrow of one here and the arrow of the second vector over here. Yes? On the other hand, when we drew the final vector, the resultant vector, we have drawn it in the opposite manner. For the resultant vector R is such that its tail coincides with the tail of the first vector, which is vector A, and its head coincides with the head of the second vector, which is vector B. So here in this case, we have taken the vector R in the opposite order of what we have taken the vectors A and B as. A and B are taken in the same order because the tail of one coincides with the head of the other, whereas vector R is taken in the opposite order because its tail coincides with the tail of one of the vectors. Okay, so this is what we mean when we say two vectors are taken in same order or vectors are taken in the opposite order. Now, do you see the statement that we have written over here essentially is corresponding to the figure that we have drawn above. When two vectors to be added are taken as two sides of a triangle taken in the same order, then their resultant is given by the closing side, which in this case is the side OQ, which is also the vector R, of the same triangle taken in the opposite order. Do we see that the statement works with the above figure? Yes. Just to understand it a little better, we will draw it once again, and we will first see how we draw the figure if we have two vectors kept separately. Let us say we have a vector A like this and a vector B like this right now. Right now they are not connected with each other, and we want to add these two vectors. These two vectors are to be added. Then according to the triangular law, we first bring the two vectors together so that the tail of the second vector coincides with the head of the first vector. Now, know this, that two vectors, any vector for that matter, can be shifted in space, and if we shift it in such a way so that we do not change its magnitude and we also do not change its direction, then the vector essentially remains the same even after shifting it from its place from one position to the other. Why we would want to do this is because we want to shift out of these two vectors, we want to shift one so that the tail of one can coincide with the head of the other, right. So here what we do is, I have drawn the vector A once again, and now what we will do is, we will shift vector B in such a way so that when we draw the vector B once again, its tail is now coinciding with the head of vector A. This is how we have shifted B. We have just brought B parallel to its original position. So, if I just show you how we have done it here, okay, this has gone a little off, I will do it again. So, when we try to shift vector B such that it is parallel to itself, but just that it is now connected with vector A. So, we have shifted vector B from here to here. And now, these vectors A and B form the two sides of a triangle taken in the same order, and their sum will be given by the third side, which is the closing side of the triangle taken in the opposite order, which we are calling now as the vector R. So, understand that this fact that the third vector has to be taken in the opposite order is very, very important. We understand why we are doing that just by the first example, the very first example that we took to understand how vector addition takes place. From there itself it is clear, right. Now, as we move further, We have one more way of representing vector addition, which we call as the parallelogram law. Parallelogram law of vector addition. Parallelogram law is only slightly different in its representation from triangular law. Otherwise, the result that we get out of a parallelogram law is the same as what we get from triangular law. It's just that the pictorial representation is slightly different. Let us first draw a figure and understand what parallelogram law is, and then maybe we will write the statement. So, according to parallelogram law, if we have two vectors to be added in such a way so that their tails are coinciding instead. Now, the tail of one is not over the head of the other, but their tails are together coinciding. Then all you need to do to get the vector sum of these two vectors is you complete the parallelogram that they form with each other, for which all you need to do is you need to draw parallel lines to each vector starting from the head of the two and see where the two parallel lines coincide. See that this gives you a parallelogram. Yes. And now the resultant of these two vectors is given simply by drawing a diagonal which starts from the same point where the two vectors were connected with each other till the opposite corner of the parallelogram. This is vector R. So, pictorially this is our parallelogram law. We can write the statement also now. So, statement of the parallelogram goes like this: if the two vectors to be added are taken as two sides of a parallelogram, then their vector sum is given by that diagonal of the parallelogram which starts from their point of intersection. Now, just to compare the two laws that we have just now discussed, the triangular law and the parallelogram law, see that since I have taken the two vectors A and B to be almost the same in both the laws, we can understand how the two laws are actually identical. See here that instead of taking vector B coinciding, the tail of vector B coinciding with the tail of vector A like this, if I just shift vector B over here, such that its tail now coincides with the head of vector A, I can always do that by shifting my vector B from here to here. If I don't change the magnitude of vector B and I don't change its direction, then that means I am not changing the vector, right? So, this is also vector B. And now see that instead of drawing the diagonal of the parallelogram, if I just complete this triangle which I am getting from the vectors A and B, I am once again getting the same vector R, yes, which I would have got by completing this parallelogram also. So, understand that the triangular law and the parallelogram law are not very different from each other. They differ only in the pictorial representation of the two vectors to be added. The final resultant vector that we get out of the two laws is essentially the same. Extension of these two laws is what we call as the polygon law. Polygon law, which we use for adding more than two vectors. More than two vectors, and know that it is nothing but an extension of the triangular law. Let us understand by a picture what it is. If we have more than 2 vectors to be added, let's say we want to add 3 vectors now, vector A to be added to vector B and also to vector C. These are 3 vectors that are to be added. According to the polygon law, then all you need to do is bring all the 3 vectors in such a way so that they form the sides of a polygon this time, taken in the same order. So we shift vectors B and C so that the tail of B coincides with the head of A and the tail of C coincides with the head of B. So this is how we get the 3 vectors connected together. And now all we need to do to get the sum of these 3 vectors is join the tail of A with the head of C. This gives us the resultant vector R, where R will be equal to vector A plus vector B plus vector C. Now I hope you have all understood how this comes. You can break this method into 2 steps. Let's say we are first trying to add vectors A and B so as to get a vector R1 using the triangular law, and then once again using the triangular law we are trying to add vector R1 with vector C, and that is when we get this resultant vector R, isn't it? So if we want, we can write this vector A and B first as vector R1 and then we can add R1 to the vector C to get the final resultant vector R. So see that, understand that polygon law is nothing but just an extension of the triangular law of vector addition. If we have to write the statement for this law, it goes like this. The statement of polygon law states that if all the vectors, whatever number of vectors you have now, you can add them using the polygon law. If all the vectors to be added are taken as sides of a polygon, taken in the same order, their resultant is given by the closing side of the polygon taken in the opposite order. Thank you.